we need to visit the idea of converses, as in the relationship for the conditional statements. So I'm in section 6.1.5, and you should open up to 6.1.5 and look for that heading called What is the Relationship? And you'll see that it says, so far in this chapter, you have completed several problems in which you were given certain information and had to determine whether triangles were congruent. But what if you already know triangles are congruent? What information can you conclude then? Thinking this way requires you to reverse your triangle congruence theorems. Today you'll look more generally at what happens when you reverse a theorem. So starting with 6-4.1, and Jorge, who's working with this diagram below, he concludes that AB must be parallel to CD, and he writes the following conditional statement to justify his reason. So take a look here. If alternate interior angles are equal, then lines are parallel. What we really see here is alternate interior angles that are congruent or that have measures that are equal. So we might want to correct Jorge's language in terms of this statement. But the idea is that the only time those alternate interior angles will create a situation where they are congruent is when AB is parallel to CD. And Margaret's got a different problem. She concludes that X must be equal to Y because she has two parallel lines that are cut by a transversal, and she can see that X and Y are alternate interior angles. So the conditional statement for this drawing is if lines are parallel, then corresponding angles are equal. We take it back. We are supposed to write a new theorem. So let's go ahead and do that. For Margaret's drawing, this is the one we're familiar with. We can make a judgment about X and Y that looks like this. If two parallel lines are cut by a transversal, and you'll be wondering what the abbreviations you can write are, and here is the shortest version I will accept. If two parallel, there's an abbreviation right there. Lines are cut by a transversal, there's an abbreviation right there. Then, and here comes another abbreviation, alt int for alternate interior. You can use the symbol for angles, and you can use the symbol for congruent. So there's Margaret's conditional statement. And Jorge and Margaret's statements are related because they contain the same parts, but the if and the then are in reverse order. Remember, Jorge's diagram looked like this, where the given information was that the angles were congruent. Now his conclusion is if two parallel lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So these two conditional statements are converses of each other. The initial statement and the conclusion are switched. So let's take a look at what they have to say in 6-4.2. In problem 641, you learned that each conditional statement has a converse. Now, we're going to test to see if all converses are true. The first statement we're asked to consider is if triangles are congruent, then corresponding sides are congruent. We conclude that this statement is indeed true. And this is written in your textbook's if-then form. Here's my if portion of the statement, and after the arrow is my then portion of the statement. Is the diagram true? Yes, we think it is. Write the converse of this arrow diagram as an arrow diagram or as a conditional statement, and then is this converse true? So we have triangles congruent, therefore corresponding sides are congruent. So let's write the conditional using the arrow diagram. We're just going to switch the statement and the conclusion. So if corresponding sides are congruent, and you should be writing these statements, then triangles are congruent. So that's our side, side, side congruence for triangles theorem. And then we'll consider another one. Let's look at C. Now consider another true congruence conjecture. If triangles are congruent, then corresponding angles are congruent. Is this one always true? Or is it only true sometimes? So first let's write its converse. We have triangles congruent, therefore corresponding angles are congruent. So let's write corresponding angles congruent. Then triangles congruent. And let's consider the possibility of the truth in that statement. So certainly we can say that they're similar. If all of the angles are congruent, we certainly have similarity, but there's nothing about this statement that shows a one-to-one correspondence. So we aren't able to say that they are in fact congruent. It's not strong enough. It only gives us similarity. In D, take a look at D, we're asked to write the converse of the arrow diagram that says if a shape is a rectangle, then the area of the shape is base times height. Let's rewrite that statement. We were given if the shape is a rectangle, then the area of the shape is base times height. So go ahead and write the converse of that statement. And you should be writing, if the area of the shape is base times height, then the shape is a rectangle, and decide on the truth value for that statement. Is it completely true all the time? Can you think of a counterexample? All you need is one counterexample to state that something isn't true enough. And certainly the area of a square is base times height. The area of a parallelogram is base times height. Neither of those figures must be a rectangle. So the statement, the converse of the statement, a shape is a rectangle, then the area of the shape is base times height, is not true. So we will be using the converse of several theorems to help us with proofs. Certainly we'll need the converse of the parallel, all the parallel lines relationships. So keep an open mind about when the converse of a particular statement is true and when the converse of a particular statement needs to be challenged.